Hello everyone. So I hope everyone's doing fine and everyone's enjoying the videos and everyone is understanding whatever is being taught through the videos. So in the last video we had started your multiple regression model. So we'll be moving ahead with that only. So today we'll be discussing the interpretation of your multiple regression model, because as we know the interpretation is really important. The entire idea of studying econometrics is the interpretation of different coefficient or the regression model. Okay, so multiple regression model is conditional upon the fixed value of the regressor, upon the fixed value of the regressor, and we obtain an average or mean value of the y variable, the y variable. So it's pretty much similar to your simple linear regression model. So where we have fixed values of fixed but different values of x, and then based on that we calculate an average value or mean value of the y variable. Okay, so for every x value we have a different y value, and then we calculate an average of that value, right? Similarly the same thing is happening, only the difference here is that we have two variables, right? Since we are studying the multiple regression model with three variables. Okay, so we have two x variables. So the difference also lies here is that your beta 2, that is the slope coefficient with respect to your x2 variable, and beta 3, that is your slope coefficient with respect to your x3 variable, are called partial regression or partial slope coefficients. Okay, because they are associated with a particular variable. Okay, that is why they are called your partial regression or your partial slope coefficients, right? So beta 2, so I'm talking about beta 2 here, it also implies the same thing for beta 3. Okay, so beta 2 measures the change in the mean value of y, that is expected value of y per unit change in x2. So we know this definition, right? We know this definition. Just a second while this slide loads. So this also goes for beta 3 and for a unit change in x2. So we are getting the mean value of y for per unit change in x2. Okay, and when we are doing this, so when we are changing the x2 variable and we are trying to find the mean value of y for the various changes that we are making, we are holding the value of x3 constant. So when we are doing this for x2, we are holding x3 constant, and when we are doing this for x3, we are holding your x2 constant, and that is why it is called the partial regression coefficient. So beta 2 gives the direct or net effect of a unit change in x2 on the mean value of y, net of any effect that x3 may have on mean y. So in a way we are trying to avoid any effect that x3 might have on the mean value of y when we are trying to vary the x2 variable. Okay, so we are just trying to focus on the independent effect of your x2 variable on the y variable, right? That is the dependent variable. So the same thing that we have just mentioned applies for your beta 3 also. So you can say replace beta 2 by beta 3 here and read the whole thing for that also, right? I hope this is clear. So, but the idea or the question here is that how do you actually go about holding the influence of a regressor constant? So how will you do it? So how do you hold the effect of a regressor constant? So if you want to find the effect of x2, how do you hold the effect of x3 constant? So there's a method. So we'll follow these steps and you will see that we can actually achieve this. Okay, so we'll be doing this with the help of an example, right? So suppose your y variable is your child mortality rate, your x2 variable is your per capita gross national product, right? PGNP. We have seen this example in the previous videos. Okay, so x3 or the extra variable here is your female literacy rate. So we have these three variables, right? And suppose we want to hold the influence of female literacy rate constant. Okay, and holding this constant, we want to see the impact of your pgnp on your child mortality, right? So that is what we'll do, and that is where we'll see how we can hold the influence of a regressor constant. Okay, now we know in statistics uh, that any variable can influence any other variable. Okay, so FLR can influence both your child mortality and your per capita gross national product. Okay, so therefore we remove the linear influence of FLR from both CM and PGNP by running a regression of CM on FLR and of PGNP on FLR. So basically what we'll do is we'll run a regression of your child mortality with FLR and of your PGNP with your FLR. Why we are doing this, we'll see. So we'll create a regression where my dependent variable is your child mortality, right? And we'll run a regression with the help of the FLR variable as the independent variable. Similarly, I'll create another regression where my dependent variable is my PGNP, that is per capita uh, gross national product, and the independent variable is my FLR variable, that is the female literacy rate. So this is what the two models will look like, right? Okay. So now if I rearrange the model, I'll get these values, or the error terms, or the unexplained part of the CM variable by the female literacy rate. So the error term or the UNI hat is basically that part of my child mortality rate that is not being explained by your female literacy rate. Okay. Similarly, my U2I hat or the error term here in this regression is that part of PGNP or per capita national uh, gross national product that is not being explained by my FLR variable. Okay, that is what the error term is, explaining. It is basically that part which is unexplainable, right? So I have two new variables now, that is equation 1 and equation 2. Okay, so equation 1 is implying basically part of child mortality left after removing from it the linear influence of FLR. So that part of child mortality which is not being explained by my FLR variable. Similarly, equation 2 is suggesting that that part of PGNP left after removing from it the linear influence of FLR. Okay, so we are left with U1I hat and U2I hat. Okay, so these are basically those part of child mortality and PGNP which are not explained by FLR. Okay, now this becomes important because we'll be using this. So what we do now is we regress U1 I hat, that is my child mortality, on U2 I hat, that part of child mortality which is not explained, and U2 I hat is basically your that part of PGNP. Sorry, what's happening? So this is basically your PGNP, unexplained PGNP, okay, or which is also being termed as your purified terms which are purified of the linear influence of FLR. Just give me a second. There's a little lag. Okay, right. So this is basically your PGNP. Okay, so U1 I hat and U2 I hat basically are purified of the linear influence of FLR to obtain the net effect of PGNP on CM. So if I regress U1 I hat on U2 I hat, I'm basically getting the net effect of PGNP on CM, because both these terms are both these terms are free of any effect of your FLR, that is female literacy rate. Okay, so if I create a regression, my regression will look like this. So the expected value of my purified CM, a child mortality rate, is basically gamma times my U21 I hat. Okay, so gamma is this is the regression coefficient of this this regression where I'm regressing U1 I hat over U2 I hat. Okay, so in this regression there will not be any intercept term, because we know that the expected value of U1 I hat and U2 I hat will be 0, because these are error terms, and we have already seen in the assumptions of the model that the error term has 0 expected value, right? Coefficient. So what is gamma representing? How do we interpret gamma? So Stope coefficient gamma gives the true effect or net effect of a unit change in PGNP on CM. Unit change of PGNP on CM, that is, it gives the partial regression coefficient of CM with respect to PGNP, right? Since we have removed from U1 I hat and U2 I hat the effects of your FLR, that is female literacy rate, that is why this regression, this, why is this not working? So this just this regression here and this coefficient that is received out of this regression gives me the true or the net effect of a unit change in PGNP on child mortality. Okay, so that is, it is giving me the partial regression coefficient that I was looking for, that is free of any impact of my female literacy rate. So this is the method through which we run the multiple regression model and we try to estimate the partial regression coefficient. So I hope this was clear, and I'll see you in the next video soon enough. So till then, take care. Have a nice day.